Hi everyone, here's the answers for the transition metal problem solving question I set on Monday. So this is a flowchart, and if you don't like flowcharts, here's one for transition metals rather than organic. So this is the solution that we start with, a pale blue copper solution, 6 waters around it with a 2+ charge. You can see reaction 1, we're reacting it with HCl. This is one of the common reactions, copper and hydrochloric acid. It's a ligand substitution reaction, and you get a yellow solution, and often while it's in equilibrium, it's kind of green when it's in that dynamic equilibrium in the middle. So you do need to know that one. It comes up quite a lot. And we swap 4 chlorines for the 6 waters. Chlorine's a big ligand, you can only fit 4 of them on. Also there's lots of negative charges which all repel. And because you've got 4 negatives, 2 positives, you've got an overall charge of 2 minus. This one here is ammonia. Now you can see here when you add a little bit of ammonia that you get a precipitate. So this is the one with ammonia where it's basically hydroxide in disguise. If it says precipitate, then you know it's going to be a precipitation reaction. This often then carries on and goes all the way through to ligand substitution if you add excess. So 2+, so you need 2 hydroxides, and then you do ligand substitution on it. Ammonia and copper is the one where you have 4 and 2. You do need to know that. It's just one of the things you need to remember. And the way I remember it is more ammonia. So 4 ammonias, 2 waters, so you don't get those two mixed up and end up doing 4 and 2. So 4 ammonias, 2 waters. They're both neutral ligands, so your charge for that is the overall charge. This one here is one of the redox reactions. There's 6 redox reactions that you need to know. They're all in your ILB and also in the textbook. And they should be in the revision guide as well. And this is the one with copper and potassium iodide. I've wrote the textbook page there. It's 419, but that's the big textbook. I think it might be in the revision guide as well. I'll have a look in a sec. So with this one, you get the white solid of copper iodide. It's not a precipitation reaction. That's a different one. That's the other copper one. This is just a straightforward redox one. And a brown solution of I2. You do need to learn this. It's only 1 mark, don't stress about it, but it does occasionally come up, and it's just one of those things that the students who've learnt it, they get an extra mark. But all in all, with your transition metals, make sure you know your colours, make sure you know those common reactions, your precipitation, your ligand substitution ones, and with the redox, try and remember as many as you can. Type of reaction 1, we've gone through that, ligand substitution. Redox number 2 is redox. Right, this is a big problem solving one. So what I've done is with this one here, because it's a 6 marker, I've put various, let me just lift this up slightly. I've put little things at the side for you to see how, which bit is going where. So nickel 2, so we know it's a nickel 2 compound. There's an MR there, percentage by mass there, 6 coordinate, 3 molecules of bidentate ligand. So all the things that are information I've highlighted there. So with these ones, please don't think you have to be able to see exactly what you're going to do. You don't, you just work your way through it, see what it tells you, see where you can go next, one step at a time. If it's a titration, you often start at the bottom, but with this one, because it's not a titration, you don't need to start at the bottom, you can start wherever. So, nickel complex A, heating in a crucible to remove water crystallization. So I've done this bit here in blue, it carries on in red at the bottom, sorry. It's up to this bit here. So that's your mass of before, that's your mass of after. So I've taken off the crucible weights so that you've got the mass of the actual solids. So we don't know much about it, so I'm just saying NiX with some waters. Its mass was 8.297. MR we don't know. A works out as 7.433. MR we told there, so that's 309.7. So we can work out a number of moles of that, which is 0.024. The water is the difference between them, so it's 0.864 divided by the MR of water, which we always know, 0.048. We can see it's a 1:2 ratio, so we know that there's going to be 2 waters of crystallisation. So that's what we've worked out for this bit here. I'll put the mark scheme up as well for you to check where the marks are allocated. So we've used that bit there that's blue. Percentage composition by mass, which is here in red. So you know how to do that. It gives you 1 to 6 to 6 to 24 to 2 when you work out the ratio. So you can see that bit there. So we know there's 1 nickel, 6 carbons, 6 nitrogens and 24 hydrogens in the cation. So that's the positive bit of it. And then of course that's got a 2+ charge. Because it must have to have 2 lots of chlorine as the negative part of it. So when we draw these things, and you can see the final thing I've got here, you get the complex, and normally you'd have square brackets and a big charge around it, and then the chlorines would sit outside that just as the other ion. So that works when you start breaking it down. This is this bit at the bottom here. It's 6 coordinates, so I've drawn my nickel here and I've put my 6 bonds around it. Remember, 1 up, 1 down, 2 forward, 2 back. 3 molecules of a bidentate ligand. So if you divide that by 3, you get C2N2H8, which when you think about it is your Ian ligand. N attaches on, because it always does, because it's the thing with the lone pairs. Attached to a C, attached to a C, attached to your N. So that's your 2 N's and your 2 C's. And if you work it out, 2, 2, 2, 2. Nicely adds up to your 8. So that bit's your ligand there. So I've drawn this bit out. Exists as optical isomers, so they want you to draw the optical isomers. There's your nickel, there's your Ian ligand, so there's one side, and then mirror image, and that is one, that is the other ligand, and then this ligand's here, and you can see those mirror images. So just for clarification, A was your full complex with your positive, negative ions and your 2 waters. B was just the anhydrous stuff minus the waters. I've put your charges on your chlorine just so you can see that, so it balances out. C was the cation, so that's just the positive bit minus that. And D was your bidentate ligand. I've put the lone pairs on so you can see that. Right. There we go. I'll put the mark scheme up as well, and I'll try and find out whether there's a page number for your redox reactions in the revision guide. Okay, thanks.